In Mr. Gale's last video, here, as well as introducing you to the idea of hypothesis testing, he made the bold claim that he was psychic, at least in the context of predicting some cards. In this video, I'm going to show you how to lay out a proper mathematical hypothesis test so that we can show whether it's actually likely, whether he is psychic or not. I think it's complete baloney, to be honest, but we'll see. We'll see. The questions that he asked in his video were these two. This one about him being psychic and this one about a multiple choice quiz. We're going to look at both of those in this video again. So have a read of these, familiarise yourself with them again, and try to make a prediction about the answers to the questions. Pause the video now and do that. Right, hopefully you've got your head around those. I'd also like you to get ready to work along with this video. What you're going to need is the Edexcel formula book open. We're going to use that. I'd like you to open this Geogebra app. The links to both of those are in the description. And I'd like you to get ready in real life as well with paper, pen, and your class whiz. Get all that ready now, pause the video, get ready. All right, let's take a look at the question again. What I want to do is write this using the language of a mathematical hypothesis test. Again, in his last video, Mr. Gale introduces some vocab, and we're going to be using that now. So if you haven't watched that video, definitely go back and watch it, but I'm assuming that you have. We need to write down our hypothesis. There are some well-known symbols here that we use. H with a little zero, H0, is our null hypothesis. That means, what if nothing happens? What if nothing happens? In this case, our null hypothesis is that the probability of predicting a card correctly is 0.5. So he's not psychic. Nothing special has happened. Our alternative hypothesis is that the probability is greater than 0.5, meaning that he's more likely than 0.5 to get things right, hence he might be a psychic. A note here that these symbols, H0 and H1, are not like variables that we normally use in maths. They're just subheadings, really. You should never be writing H0 equals something. Imagine it as a subheading, so this might be underlined saying our null hypothesis is this. Never, 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 never treat it like a variable like P is here. We need to write what we mean by P. In order to do that, we need to write down what our variable is, what our random variable is. Let's use X, where X is going to be the number of successful predictions that he makes. Now he could make 0 successful predictions, he could make 8 or any number in between. This random variable is binomially distributed with n equals 8 number of trials, and probability P. We're just going to write P here because P changes depending whether this is right or this is right, depending which hypothesis is right. How does this random variable look like on a graph? That's what the Geogebra app is for. Here we go. When you open it up, it looks like this. We want to change n to 8. And we're going to draw it as though the null hypothesis was true. So given that P is 0.5, given that he's not psychic, these are the probabilities of getting each number. So it's most likely for him to get 4 correct, and it's not very likely for him to get none correct or 8 correct. Now, what are we looking for here? We're looking for a cutoff up here such that if he got a really high number of successes, we'd be like, oh, that is so unlikely then it must be the case that he's psychic. We don't know exactly where that cutoff's going to be. Maybe it's 8, maybe it's 7, and we need to decide where that cutoff's going to be. Let's write that using a bit of maths as well. We're looking for a cutoff value, x, little x, this is a value, such that if our random variable was that bigger than or equal to it, the probability of that would be really low. How low depends on the significance level of the test, how confident we want to be. Again, Mr. Gale mentioned significance level. Suppose I want to be 95% confident in the result of this test. Then our significance level would have to be 5% or 0.05. Meaning any value, a probability less than that, if it was that unlikely, we're going to say that he is psychic. I'm going to write down what our significance level is there. Significance level is 5% or 0.05. It doesn't matter how you write that. Okay, we need to find some probabilities now. We need to find this probability. I'm going to show you how to do it using the class whiz first. We need distribution mode. That's mode number 7. We need the binomial CD, because we're interested in inequality rather than equals. And I'm going to want a list. Now I'm going to list out a few different numbers up this top range so we can just investigate and have a look what the probabilities are up there. So let's choose... Now let's go 5 first. 5, 6, 7, 8. Romeo, Romeo. That's a song, right? Okay, I put the numbers in the list. N is 8. Under our null hypothesis, P is 0.5. Great, I've got them up there, and I'm just going to write these out. So what have we got? What does that mean? Well, that means... Well, the calculator gives us less than or equal to values. The cumulative distribution does. So 0.8554, and obviously less than or equal to 8 is 1, because that's all we can get. I've used my calculator to get these values here. A quick note as to why I asked you to open the formula book, because we can get these from the formula book as well. You're used to using the formulas in the formula book right at the top, but if we scroll down, if we flick through the formula book, there is a page called the binomial distribution. That's it. Yes, the binomial cumulative distribution function. Now, some people prefer to use this than the class whiz, just because all the numbers are sort of here already. Right, so what are we looking for? We're looking for n equals 8. We're looking for p is 0.5. And you'll see, hopefully, the values here are the values that we wrote down. I think it's rounded it slightly differently, because we wrote 0.8554 there, and 0.9648, that's what we wrote. 0.9960, that's what we wrote there. But that's just the 4th decimal place. The values that we got off the calculator are there. It's your choice in an exam whether you prefer doing it how we did it on the calculator or learning how to look them up in the tables there. Different people's preferences. It's just finding a probability. Importantly, we've got the probabilities written down. The next step is a step where people make a lot of mistakes. Note that we want a greater than or equal to here, but these are less than or equal to's. So we need to write these in terms of greater than or equal to's. Let's do that. This first one, probability of x is less than or equal to 5. The opposite of that is greater than or equal to 6. Let me just remind you what that means. Less than or equal to 5 is to the left of here, and the opposite of that is greater than or equal to 6. There's a common mistake, not swapping that 5 for a 6. But that's why we're writing all of these down. So if we take this value away from 1, we'll get this probability. That is 0.1446, 14.46%. I'll do it quickly for the other ones. All right, we have them there. Which one of these do we want? We're looking for the first one that is less than or equal to 0.05, and that is that one. So what have we found there? Let's write it out over here. Well, the probability that x is greater than or equal to 7 is 0.0352. That's the first one that was less than our significance level, and so our critical region is saying that if he gets greater than or equal to 7, we're going to believe him. We're going to say that there's evidence to accept the alternative hypothesis. We're going to believe him. I'll write that down. The critical region is greater than or equal to 7. Right, some curly brackets and underline it. Fantastic. So now if he does the test, if he actually does this and gets greater than or equal to 7, we can say that we are 95% confident that he is psychic, or at least there might be something going on. Note quickly that the actual value here of the probability wasn't 0.05, it was the first one that was less than it. But the actual significance level, and that's a term that you need to know, the actual significance level is 3.52%. That's how unlikely it is for him to be up there. Suppose I stated that I wanted a significance level of 1%. The first one under 1% was this one, and so our critical region would be even narrower, and we'd say he would only have to, 8 is the only thing that he could get for us to believe that he was psychic. That's the first one where we could be over 99% confident in the result. Okay, I'm going to leave that to him to try and do that experiment and actually figure that out, actually see what comes out of it. We're going to move on now to that other example, this one, and try to lay it out in exactly the same way. Try, perhaps, to give it a go yourself first. Have a read of it and try to lay it out as we just did. Go on, pause the video and have a go. Okay, the first bit is going to look exactly the same. Our subheadings, H0 and H1. What is our null hypothesis here? It's that the probability is just a fifth. So that they are randomly guessing. Our alternative hypothesis, in this case, is that it's less than a fifth. That Geraldine is answering this such that her probability of getting a correct answer is less than if she was just randomly guessing. She's deliberately getting things wrong. What's the random variable that we're using here? It's binomial again. In this case, n is 20, probability p, and x is, let's put some words to this, the number of correct questions. Note how it looks exactly the same, well, almost exactly the same. The layout is exactly the same as the previous question, and I've got at least 1 mark already in the exam. Let's write down what we want. We want a value of little x such that our random variable, if it was less than that, less than or equal to that, the probability is so small that we'll believe that Geraldine is deliberately getting things wrong. Let's choose a significance level. Let's use 5% again. That's a common one. So the significance level is 5%. All right. Hopefully, if you'd had a go yourself, then you've written down something like that. Let's find the probabilities again. I'm going to show you both ways again. Calculator, binomial CD, list. So we're looking for the bottom end this time because we want it really small. We're looking for the bottom end, so let's try x is 0, 1, 2, 3, 4. If it's not in this range, then we'll just have to check again. We'll just check again. N is 20 and P is 0.2. Took a bit of time there. So let's write out a couple of these. The probability of x less than or equal to 0, or equals 0, is 0.0115. X is less than or equal to 1 is 0.09691. I think I only need to write down those two because that's already passing the 5%. Show you quickly how to find those in the table. Let's get back to the table, just in case you liked the table. We've got n is 20, so we need to go to the next page. N is 20, the probability is 0.2, so that's this column here. And we get here the probabilities that we wrote down, again with a little rounding difference there, but it's not too different. Exam would still accept it. Those are the two values that we got. Alright. Now this case is slightly easier because these are already in the form that we want. We're looking for a less than. Which is the first one that's less than 5%? Well, this one's already over 5%, so it's this one. We've got the probability of x is less than or equal to 0 is 0.0115. And because this one is already over 5%, then our critical region is just this. Our critical region is just x equals 0. Meaning that we can only be 95% confident, or more than 95% confident, that Geraldine is deliberately getting things wrong if she actually gets a full 0 on the test. Then we'll be like, Geraldine, why don't you want the responsibility? Note the actual significance level again. It was the first one that was less than 5%, but the actual significance level is 1.15%. There we go. Note that in this one, if we wanted a significance level of 1%, that wouldn't have been possible. Meaning, we could never have been that confident that Geraldine was deliberately getting things wrong. She would have to answer more questions or something in order for us to be that confident. Okay, so whenever you're finding critical regions or doing a question like this, make sure your working is spot on. We've got the hypothesis tests written out clearly. We've got probabilities from the calculator or from the formula book written out explicitly. Especially important to the ones that are either side of the significance level. We've got final answer stated, and if it's one that you need to swap from less than to greater than because your hypothesis is to do with a greater than, you're really clear with your working, not only for marks, but to get it right in your own head so that you don't make a mistake. I'm looking forward to Mr. Gale putting that to the test.